We need to find out the value of the given trigonometric expression. So let us begin. So we will first try to reduce each of the trigonometric ratio. So that means simplify. Let's begin with our first ratio. We have tangent of 90 degree minus theta, which can be also expressed as tangent of 1 multiplied to 90 degree minus theta. So here we have an odd multiple of 90 degree because 1 is an odd number. So whenever we have an odd multiple of 90 degree, then the tangent function transforms to cotangent function and the new angle will be theta. We'll also have to check in which quadrant it lies. So we have 1 times 90, that means we are in the first quadrant, and subtracting theta from it, we're going to still lie in the first quadrant with theta lying between 0 and 90 degrees. So in the first quadrant, all trig functions are positive. So tangent of 90 degree minus theta is equivalent to cotangent of theta. Coming to the next one, we have secant of 180 degrees minus theta. That can be also expressed as secant of 2 times 90, so that's 180 minus theta. Now we have an even multiple of 90 degree. Whenever we have an even multiple of 90 degree, then secant is not going to transform, it's going to remain as secant and the new angle is going to be theta. Now 2 times 90 means we are in the second quadrant, because in the first quadrant we started out with 1 times 90, then we always go into anti-clockwise fashion. So 2 times 90 is going to land us in the second quadrant. But then again, we are also subtracting theta from it. Since theta is an acute angle with a value between 0 and 90 degree, so we are still going to lie in the second quadrant. In the second quadrant, the sine and the cosecant functions are positive. Everything else is negative, so our value is going to be negative. We will get negative secant theta. Now coming to sine of negative theta. Now sine is an odd function. So sine of negative theta is equivalent to negative sine theta. Fine. Coming to sine 180 degrees plus theta. So we can rewrite it as sine 2 times 90 degrees plus theta. So we have an even multiple of 90 degrees. So sine is going to remain as sine and the angle will be theta. But 2 times 90 means we are in the second quadrant. But addition of theta means we are adding an extra angle theta to it, whose value is lying between 0 and 90 degree, is going to take us to the third quadrant. Now in the third quadrant, tangent and cotangent are positive. Everything else is negative. So this value is going to be negative sine theta. Coming to the cotangent function, so we're cotangent of 360 degrees minus theta. Now 360 degrees can be also expressed as 4 times 90 degree minus theta. Now 4 is an even number, so cotangent function is not going to transform, it's going to remain as cotangent, but our angle will be theta. Now 4 times 90 means we are in the first, second, third and fourth quadrant. Also we're subtracting theta from it, but theta being a small angle, we're still going to lie in the fourth quadrant, where cosine and secant are positive, everything else is going to be negative. So this value will be negative cotangent of theta. And finally we come to cosecant of 90 degree minus theta. So that's equivalent to cosecant of 1 times 90 degree minus theta. So we have an odd multiple of 90 degrees. So cosecant must transform to secant. We're going to get secant theta. And we are in the first quadrant where everything is positive. So now that we have all the values, so let's substitute them into our given expression to get. So we have tangent of 90 degree minus theta, which you can replace with cotangent of theta, multiplied to secant of 180 degree minus theta, we got it as negative secant theta, multiplied to sine negative theta, so that's negative sine theta. So this is given here, and in the denominator we have sine 180 degree plus theta, so that came out to be negative sine theta, multiplied to cotangent of 360 minus theta, so we have negative cotangent of theta. And finally, we have cosecant of 90 degree minus theta. So that came out as positive secant theta. So we'll see there's a couple of factors where terms will get factored out. So we have cotangent of theta, secant theta, sine theta, and sine theta cancelling out. So we're left with negative 1 in the numerator. Similarly, in the denominator, we have negative 1 times negative 1, which is actually positive 1. So that means the value of the given trigonometric expression is going to be equals to 1.